Hello, my name is Kyle Slolzik, and I am doing a presentation on VLAN trunking, also known as VTP. This presentation is for ICTN 2158 with Mr. Pickard. So what is trunking? Trunking, or VTP, is a protocol used to synchronize VLAN information across multiple switches. In order to do that, the switches tag all headers with the VLAN ID. This allows other switches to forward these packets to the correct VLANs. Once this tagging is done, the switch sends these frames out special links called trunk links. I will show you how to configure these later in the presentation. In order to use VTP, you must know that there are two different encapsulation methods. The first, 802.1q, is an open standard developed by the IEEE. The second is ISL, which is a Cisco proprietary standard and really a dead technology. When you set up VTP, each switch is set to one of three modes. The first is the VTP server. The server is where you, as the network administrator, would create or make changes to existing VLANs. Once these changes are made, the switch sends out a VTP update on all of its trunk links. This VTP update contains the information that you just set. By default, every switch is set to be a VTP server. The second mode is the VTP client. The client can only receive and process VTP updates. If you make a change to it on a client, that change will not be included in the VTP update. When a client receives a VTP update, it processes it and forwards that update out all of its trunk links. The third and final mode is VTP transparent. Transparent switches will not process any VTP updates that they receive. Therefore, the VLANs on transparent switches cannot talk to VLANs on other switches without the help of a router. A transparent switch will forward VTP updates that it receives. In order to make VTP work on your network, there are a few things that you must do. First, there must be a trunk link between the switches on your network. Second, at least one switch on the network must be a VTP server. Then finally, you must set a proper domain and password for VTP. These domains and passwords are case sensitive, so be careful when you set them. In the next section, I will demonstrate how to set up a network using VTP. I will now switch over to Packet Tracer and show you how to set up a network using VTP. Notice how I have a network with three switches. Each switch is connected to the other switches by two crossover cables. This is important because switches cannot talk to each other via a straight through. Let's take a look at the configuration on switch 1. We will make switch 1 the server by using the VTP commands. The first command that we must type is VTP mode server. This will set S1 as the VTP server. Next we type VTP domain CCNA. This sets the VTP domain name to CCNA. Remember that domain names and passwords are case sensitive. Finally, we set the VTP password by typing VTP password Cisco. Now S1 is set up as the VTP server. We will use similar commands on S2 and S3 as clients. Now we will open S2 and set it up as a client. We type VTP mode client to set S2 as a client. We will also set the domain name and passwords now. Follow the same steps for S3. Now we must set up the trunk links so that the switches can talk to each other. Let's start with S1. The 4 ports that are used as trunk links are FA0/1 through FA0/4. First, select these ports by using the range command. Next, set those ports to trunk links by typing switch port mode trunk. Finally, set the native VLAN by typing switch port trunk native VLAN 99. You'll need to repeat these steps on all 3 switches. Now you have a working VTP network. Create a few VLANs on S1 and see them filter down to S2 and S3. Make sure you create VLAN 99 because you set it as the native VLAN in your trunk setup. By using the show VLAN brief, you can see that the VLANs have filtered down. Notice that we now have VLAN 10, 20, and 99 on S2. And on S3. Thank you for watching my presentation on VTP Trunking. I hope this was helpful.